Back. We're going to look at another example Fourier series. This will be our second example. So for this problem, you see we're going from negative pi to 0 and from 0 to pi. So our period, if for this one is 2 pi, and the length is half of the period, which is pi. We now want to sketch the graph of this function. So from negative pi to 0, we have x, which looks like we should start at here and go up to here. And then from 0 to pi, it is 0. And then we just need to sketch it for 3 more periods. Actually, wait, this is only 2 periods. That's fine. Yeah, this is only 2 periods, by the way. Not 3 periods. Three periods would be 1 more. But, you know, this is enough to get the idea. You don't have to do 3 periods. Okay, part B. I already have the formulas written out. So let's go ahead and start integrating. So let's solve for A naught. For A naught, see if I remember these formulas. We have our length is pi this time. It's x, right? From negative pi to 0. Yes. It's x dx. And we also have the other term, but this one is 0 over this interval, so we can just ignore that term. So now this becomes 1 over pi times 0 minus, sorry, this is supposed to be negative. Doesn't matter anyways. Is that correct? Negative pi over 2? Let me check. Yes, it is. A naught is negative pi over 2. A sub n. Once again, we can ignore the second half because it's 0. But this is negative pi to 0 of x. Cosine n pi x over L, which is pi, does cancel. U is x, dv, I'm sorry, dx, du, dx, dv is just nx, so then v would just be right. We have uv minus integral v du. Pull that out. Remember, we have to evaluate in the limits there. Okay, so let's now evaluate this. So let's have 1 over pi times, oh, that's just 0. You know why? Because sine, I should have known that. Sine of n pi is 0. You can do it out if you want. Let's look at the second half. That would be what? Negative cosine? Negative 1 over n cosine? nx from negative pi to 0. Yeah. Okay. So let's evaluate this. 1 over pi times negative 1 over n times negative 1 over n minus, so that's plus 1 over n cosine of negative n pi. Now, I'm going to remind you that cosine, remember, because cosine is even, of negative anything is equal to that, right? Because it's even. So you can just get rid of that negative from in there. And then we're left with this. So now, this becomes 1 over pi times 1 over n squared minus 1 over n squared times cosine of n pi. Now remember, cosine of n pi is equal to negative 1 to the n. So a sub n, I'm going to pull out n squared 1 minus negative 1 to the n. Now, you'll remember from my shortcut or my simplification video, this can be simplified even further at this point, right? Because you can see that if n is even, if you try that out, say n's 2, then this would become 1 minus 1, which is 0. So that a sub n would be 0. But if n is odd, this would become 1 plus 1, which is 2 over pi n squared. So this is our a sub n for n odd. Let me box that whole section. Okay, that's our a sub n. Now let's look at b sub n. We have 1 over pi integral negative pi to 0. What was it? X. This one is sine n pi x over pi. Pi's cancel. Dx. This becomes, well, actually, let me just do the u sub. Sine n pi, I'm sorry, nx. This would be negative 1 over n cosine nx. We have uv nx evaluated minus integral v. I'm taking out the negative 1 over n v du, so this is okay. This becomes 0 plus x over n. Well, it'll still be minus pi over n times cosine. Now this will be negative, but remember, cosine of anything negative is equal to cosine of anything positive. Bam. And then I can tell you right now this is 0 because sine of n pi is 0. So what we're left with here, whoops, would be negative negative What is that pi doing in there? Wait a minute. Oh, yeah. Because remember, there's this 1 over pi over here. I completely forgot to write that down here. So this pi would cancel. So then we're left with negative 1 over n times negative 1 to the n, right? Because now, can this be rewritten even more? Yes, it can. Yes, it can. This can be rewritten as, yeah, because remember, negative times to negative 1 to the n can be rewritten as negative 1 to the n plus 1. So we get rid of that negative sign. So this is our, I believe, our final b sub n. Okay. So now all that's left, remember, if you want to figure out where that came from, go back to my simplification video I did. Okay, so now we can write out our solution. Remember, it's a sub naught over L, so we have, I'm sorry, a sub naught over 2. A sub naught was negative pi over 2 over 2 plus the sum. Now we have two sums here because we have a sub n is when n is odd. So this is for n odd, where we had 2 over pi n squared. This would be cosine nx. And then we have the normal, because b sub n still works for n equals 1 and so on, of 1 over n, negative 1 to the n plus 1 times sine of nx. Yep. And then the first two terms can be rewritten more. Oh, that would be negative pi over 4 plus, what would that be? Oh yes, because n odd is equal to 2m minus 1. That always will make it odd, but you have to introduce a new variable for that, right? So what we're going to do is we're going to introduce a new variable, m, and we're going to plug in n odd into here. So this is pi times 2m minus 1 squared. See how that works? We just plug this in over here. Like that. And then this is just, this stays the same. But you'll notice, maybe, I mean, this answer is fine, you know. The answer's been fine since the beginning. You know, this is a fine answer, you know. But you'll notice, you may notice that when we increment by 1 m and 1 n, we'll get the same answer. So why not we just have one series, so we can combine it into one series. When you combine it, you're going to create a new variable. We'll call it k. It doesn't matter. You can even call it n again, you know, but just for clarity, we'll call it k. K equals 1 to infinity of 2 over pi times 2 k minus 1 squared times cosine 2k minus 1 times x. Plus 1 over k times negative 1 to the k plus 1 times sine of kx. Now remember, the other way you could have written this, simple enough, you simply just would just have a minus here. That's the same thing, right? But remember, I rewrote it like this. Just because I don't like the negatives there, you know? So then this is our final answer. Not too bad, right? Put that in green. Not too bad. This is definitely the longest part of solving a PDE, right? So that's the answer to this. Let me just double check this real quick. Oh, by the way, if you wanted to, you can take out that 2 over pi there and write it like that. Okay? So then this is probably as simplified as it's going to get. I don't see how you can simplify that anymore. And I believe the next video is also another piecewise. Let's take a look. Yes, it is. And it's going to be a longer one, too. So, actually, I don't think it's too bad. We'll take a look at it. So, hope to see you for the next example. There is 3 more left. I'll see you.